Around Earth is an invisible region shaped by our magnetic field. It bends and redirects much of the charged material constantly streaming outward from the sun for our changing planet. NASA calls this region the Magnetosphere. This film asks what would change if that protective environment suddenly went quiet, an impossible thought experiment for Earth, not a forecast of tomorrow. The field is not a shell made of metal. Motion in Earth's molten outer core generates the magnetic environment, while the solar wind presses against it from outside, across space. On the sun-facing side, the magnetosphere is compressed by the solar wind. Behind Earth, it stretches into a tail that can reach beyond the moon in the night-side direction. Now draw the boundary clearly. Everything measured ends with the dynamic magnetosphere we observe today. Everything after this sentence is fiction. The field becomes quiet, and the imagined cascade begins. The first change would not be a crack above the clouds. It would begin where solar particles would encounter less resistance before reaching near-Earth space, in this imagined scenario. Auroras might become unfamiliar, brighter in some places or absent in others. But this is directional speculation, not a timetable, location forecast, or promise of spectacle under real conditions. Satellites would face a harsher environment. Their operators would have less of the buffer that normally diverts and traps energetic particles above the atmosphere, changing the risk around operations. NASA studies space weather because magnetic storms can disturb spacecraft, communications, navigation, and power systems. Here, that familiar stress becomes a permanent background condition, rather than an occasional disturbance. That does not mean every radio, satellite, or power line would fail at once. Each system has different shielding, redundancy, exposure, and operating limits we cannot calculate here precisely. Above the weather, the upper atmosphere would meet more energetic particles directly. The chemistry and electrical behavior there could change, but the timescale, size, and direction remain uncertain. Earth's atmosphere is another protective layer around the planet. Even in this thought experiment, it would not vanish. It would remain part of a changing, layered defense against incoming energy. Without the usual magnetic deflection, the solar wind would interact with the upper atmosphere more directly. The planet would become a space weather laboratory with unfamiliar boundaries and uncertain results. What that would mean at the ground is not a simple answer. Radiation, altitude, atmosphere, solar conditions, and time would all matter, so no film invents a dose without evidence. The clearest consequence might be technological rather than visible. More complicated spacecraft operations, less predictable links, and a burden on systems built for near-Earth space, not instant planetary collapse. Real magnetic fields do change over time. NASA describes shifting strength, moving poles, storms, and reversals, but none of those facts says Earth's field can simply switch off tomorrow. A pole reversal is a slow reorganization lasting hundreds to thousands of years. NASA says the field weakens and becomes complicated, but it does not disappear overnight or on command. Our quiet shield scenario is more extreme than a reversal. It removes the magnetic behavior that organizes how solar energy and charged particles are guided around the planet, in fiction. Today, the night-side magnetic tail stores and releases energy during space weather events. In this thought experiment, that architecture would no longer behave like the system scientists recognize or predict. The result would not be one disaster sequence. It would be a messy overlap of spacecraft risk, atmospheric change, uncertain biology, and decisions made with incomplete information across many timescales. The point is not to predict an apocalypse. It is to reveal how much modern life depends on invisible planetary systems that are usually noticed only when they become disturbed. In reality, Earth's magnetosphere is dynamic and responding. It responds to the sun, changes shape, produces auroras, and helps researchers understand the space environment around our home from orbit outward. So the question is not whether the shield is failing. It is what its quiet absence would teach us about radiation, technology, atmosphere, and planetary habitability if nature allowed it. This video is an original AI-generated thought experiment, not a forecast. The scenes are synthetic, the mechanism is real, and the next question begins with another Earth system.